Hi everyone. In this video, we will continue to talk about dynamic efficiency, and we will introduce a new concept, user cost. So before we jump to that, we first review the materials in the last video. In the last video, we talk about the present value and the future value. So suppose you will receive a one-time benefit, and the amount of this one-time benefit is Bn. You will receive this benefit after n years with interest rate R. So what is the present value of this Bn? So the present value of this Bn is determined by this equation. And then suppose you would receive a stream of net benefits over a period n years at interest rate R. Then what is the present value of this stream of net benefits? I can calculate the present value of a stream of net benefits by this equation. In period 0, I receive B0. Then in this period, the present value of B0 is still B0, right? So suppose in period 1, I receive amount B1. Then suppose there is an interest rate equal to R. The present value of B1 in period 1 should be equal to B1 over 1 plus R hat 1. And then suppose I receive B2 in period 2. Then the present value of B2 in period 2 should be equal to B2 over 1 plus R hat 2. And we repeat the process over and over until we receive all the benefits in n years. So that is the equation we need to use to calculate the present value of a stream of net benefits. So make sure you can make the difference between those two equations. For the first one, you just receive a one-time benefit after n years, and then you calculate the present value of this one-time benefit. And for the second one, you receive a stream of net benefits over n years, and then you calculate the present value of this stream of net benefits. So that is about the the present value and future value. Also, we talk about what makes something dynamic. The first condition is systematic link. The behavior today will affect the outcome in the future. And the second condition is forward-looking. We pick the optimal stream of actions for the entire time. Then we talk about the dynamic efficiency. Remember, in a single period, the condition for dynamic efficiency is very simple. We just need to let the marginal benefit is equal to marginal cost. Then the net difference between total benefits and total cost is maximized. So that is the condition for for efficiency in a single period. However, suppose there are only 20 units of the resource exist, and if the discount rate is 10%, and if there are 2 periods, how would you allocate the scarce resource between the 2 periods? And from the graph, we know the marginal benefit curve is 8 minus 0.4 times Q, and the marginal cost curve is 2 is equal to 2. And when we know the marginal benefit and the marginal cost, we can know the marginal net benefits in period 1, which should be the difference of marginal benefits and the marginal costs. So we just calculate 8 minus 0.4 times Q minus 2, which is equal to 6 minus 0.4 times Q, and Q is the quantity consumed in period 1. And then we go to the period 2. The marginal net benefit curve in period 2 is exactly the same as the marginal net benefit curve in period 1, because in period 2 we have the same marginal benefit curve and we have the same marginal cost curve. So we just make a difference between those two curves. Then we get our marginal net benefit curve for period 2. However, we are in today's dollars, so we need to convert the marginal net benefit in period 2 back to period 1. So that means we need to discount the marginal net benefit in period 2. So we need to calculate the present value of marginal net benefit in period 2. So given the interest rate is equal to 10%, the present value of MNB2 is equal to minus 0.4 times Q2 plus 6 over 1.1, and we get 1.1 from 1 plus 10%. 10% is our discount rate. So given this equation, we can get the present value of marginal net benefit in period 2 is equal to minus 0.36 times Q2 plus 5.45, and go back to the present value of marginal benefit in period 1. Q1 is the quantity consumed in period 1. And when we draw all those two curves on the graph, the black curve is the marginal net benefit in period 1, and the orange curve is the present value of marginal net benefit in period 2. So the optimal level of consumption for period 1 and period 2 is decided by the intersection of those two lines. So why? First, we will look at the x-axis from the left end to the right end. The x-axis represents the quantity consumed in period 1 from right end to the left end. The x-axis represents the amount that we can consume in period 2. So I already say that this point, the intersection of those two lines, is our optimal level of resource allocation. So the corresponding quantity is the optimal quantity to consume in period 1, and also 20 minus this quantity is the optimal level we can consume in period 2. So suppose we consume more in period 1. Suppose we consume 13 units in period 1. Then the total net benefit would be enclosed by the green line. Because the total net benefit from consuming 13 units in period 1 is enclosed by the green line on the left and also the blue line. The total net benefit for consuming 7 units in period 2 is enclosed by the green lines on the right and the blue line. So the total net benefits would be enclosed by the green lines. However, comparing to the optimal resource allocation, we say the total net benefit is the whole area under those two curves. So there would be a deadweight loss by choosing to consume more in period 1. Suppose we choose to consume less in period 1. We only consume 7 units in period 1 and consume 13 units in period 2. Then the total area the total net benefits will be enclosed by the green lines, and comparing to the optimal level of consumption, there will still be a deadweight loss. You can see the deadweight loss on the graph. So that's what I mean. The intersection of those two marginal net benefits line is the optimal level, or we can see the efficiency level of consumption. Then we do little math to see how we get the exact number of the quantity to consume in period 1 and period 2. We suppose there are only 20 units, right? So the total units we can consume in 2 periods should be equal to 20. That means Q1 plus Q2 is 20. So this one is our first condition. And then we know the efficiency level is achieved when we have present value of marginal net benefit in period 1 equal to the present value of marginal net benefit in period 2. That means the efficiency level is achieved when we have PV-MNB1 is equal to PV-MNB2, and PV-MNB1 is equal to minus 0.4 times Q1 plus 6, and PV-MNB2 is equal to minus 36 times Q2 plus 5.45. So we just let those two terms equal to each other, and we plug the resource constraint back to equation 2. Then we can solve for quantity 1, the quantity we consume in the first period. According to quantity 1, we can consume the quantity 2, which is decided by 20 minus Q1. So according to the math, our Q1 is equal to 10.2, and our Q2 is equal to 9.8 when there is a discount rate equal to 10%. So all we want to know is that we want to maximize the present value of net benefits. We want to maximize the sum of present value in period 2 and period 1. If there is no scarcity, then it is just a bunch of static problems. We can just consume 15 units in each period. However, there is scarcity, so we need to consume all the resource at the end of period 2, and we will consume more in period 1 than in period 2 due to the discounting. The condition for achieving efficiency level is that present value of marginal net benefit in period 1 is equal to present value of marginal net benefit in period 2. So this is our condition for efficiency level, and we also call this dynamic equal marginal principle. So here I have a question: why is the quantity consumed in period 1 more than the quantity consumed in period 2? Because there is time preference. We discount future values. The present value of benefits received in the future is lower than the value of benefits today. And that also means when present value of marginal net benefits are equal, the quantity consumed in the current time period is more than what will be consumed in the future. So here we ask why dynamic efficiency maximizes present value of net benefits. So that means why the intersection, what we consumed at the intersection maximizes present value of net benefits. So I already talked before, when we consumed at this level in period 1 and this amount in period 2, the total net benefit is the sum of the red area and the purple area, it is maximized. So if we choose another allocation, suppose we consume more in period 1 and consume less in period 2 comparing to the efficiency level, then there would be a deadweight loss due to the inefficient allocation. And suppose we consume less in period 1 and consume more in period 2, there would also be a deadweight loss according to the inefficient allocation. Intertemporal efficiency. Present value of marginal net benefit of the other period can be viewed as the opportunity cost of consuming in the first period. So in this case, there are no benefits for us to leave anything unconsumed in period 2. So when we are allocating resource where present value of marginal net benefit in period 1 is not equal to present value of marginal net benefit in period 2, we cannot get the efficient results. Then let's talk about the discount rate. In this case, the discount rate is equal to 10%, right? When the discount rate increases from 10% to 50%. So that means if we are going to calculate the present value of marginal net benefit in period 2, we need to discount more. So the initial line for the marginal net benefit in period 2 is the orange one. And when we change the discount rate to 50%, the green line represents the marginal net benefit, the present value of marginal net benefit in period 2. So we can see if we discount more, the intersection of those two lines moves to the right. That means we need to consume more in period 1 and less in period 2. And how about what will happen if we decrease the discount rate from 50% to 0? So the orange line represents the present value of marginal net benefit in period 2, and the blue line represents the present value of marginal net benefit in period 2 when the discount rate is equal to 10. So we can say the blue line, when there is 0 discount rate, the blue line is exactly same as the black line. So the intersection of those two lines should be equal to 10. That means we consume equal amount of resource in each period. So there is opportunity cost due to intertemporal scarcity. What we consume today will reduce what is available for tomorrow. And now we will talk about a very important concept, marginal user cost. Marginal user cost is the present value of foregone future opportunity at the margin. So it is also defined as the cost of an additional unit of future consumption foregone due to an additional unit consumed now. So if we fail to account for scarcity cost, we are inefficient. And how can we get the marginal user cost? It is calculated by the difference between price and marginal consumption cost. Then let's think about an example of the marginal user cost, water scarcity. So by allowing residents to use water now for less important reasons, like water the lungs, we are limiting our resource to use water in the future for more important reasons, like for surviving, for drinking. So marginal user cost typically increase with scarcity. If the resource is more scarce, then the marginal user cost for that kind of resource would be higher. Then let's go back to our graph to see how can we get the marginal user cost in different periods. Suppose we consume 10.238 in period 1, then the corresponding price would be 3.905, right? So we already know the marginal user cost is calculated by the difference between price and the marginal costs. And the marginal costs in 2 periods is 2. So the marginal user cost in period 1 is equal to 3.905 minus 2, which is 1.905. And then let's think about the case in period 2. So in period 2, suppose we consume 9.762 amount, and then the corresponding price is 4.094095, and the marginal cost in period 2 is still 2. So that means the marginal user cost, the difference of the price and marginal cost, is equal to 2.095. So be attention here. The marginal benefits curve in period 2, when we are calculating the marginal user cost, is exactly same as the marginal benefits in period 1. So when we are calculating the marginal user cost in 2 periods, we don't need to think about the present value, something like that. We just replace the quantity back to their marginal benefits curve, get the corresponding price, and then we make the difference between the price and the marginal benefit. So the only place we need to think about the present value, the discount rate, is something like this. We need to get the intersection of 2 present value of marginal net benefits in 2 periods. So for here, we don't really need to think about discount rate or present value. So be careful when you get this question in your assignment or exam. Then we can also do a math to get all the formulas or to get all the marginal cost we need. So first, given the marginal benefits on the graph, marginal benefits curve on the graph, we need to calculate the slope of this graph, and m is the slope. So m is equal to minus 0.4. Then we plug the slope back to the equation. We get the marginal benefits curve equal to p equals to minus 4 times q plus 8. And suppose we consume 0, then the price would be 8. So it is just this equation. So the equation is same in 2 periods. And in period 1, suppose we consume this amount, and in period 2, we consume this amount. Then we plug this amount back to the equation, we get the corresponding price. The corresponding price for period 1 is equal to 3.905, and the corresponding price in period 2 is equal to 4.095. The marginal consumption cost, our typical marginal cost, is equal to 2 in 2 periods. So the marginal user cost would be the difference between price and marginal consumption cost. The marginal user cost in period 1 is equal to 1.905. In period 2 is equal to 2.095. So that means the good is more scarce in period 2. So the marginal user cost is also higher in that period. And here's a take-home message. Marginal user costs increase over time for scarce results, even though the present value are equalized. That means the nominal price of the results increases. And here is a reference for this video. And remember what we talked about in this video. We first review the present value and the future value, and then we talk about the dynamic efficiency. We talk about how to get the dynamic efficiency when there are two periods with an interest rate or with a discount rate equal to 10%. So given the efficiency level of allocation, we go ahead to talk about the marginal user cost. It is in our final section. We talk about the marginal user cost, how to get the user cost on the graph, or how to calculate the marginal user cost by math. So that's all about this video. See you next time.